take a look at this problem. We got A is equal to 100,000. R is equal to 9%, or 0.09. And T is 20. And the first four are giving you n values. So n is equal to 1, n is equal to 4, 12, and 365. So formula we're going to use there is A is equal to P times 1 plus R over N to the NT power. Now I want to solve this for P, so we're going to divide both sides by 1 plus R over N to the NT power. So we got A over 1 plus R over N to the NT power is equal to P times 1 plus R over N to the NT power all over 1 plus R over N to the NT power. When I'm going to do that, these 1 plus R over N to the NT powers cancel. And we get P is equal to A over 1 plus R over N to the NT power. Now this is a formula we're going to use for the first four. So our first one, n is equal to 1. We're doing this box right here. Well, we'll plug in everything we're given using this formula right here. A is 100,000 over 1 plus R, which is 9%, 0.09, divided by N, which is 1, raised to the NT power, which would be 1 times 20. So we got 100,000 over 1 plus 0.09, 1 times 20 gives us 20. So let's see what that gives us. So we got 100,000 divided by, beginning parentheses, 1 plus 0.09, closing parentheses, caret 20, enter. And we get $17,843 and 9 cents. And that would be our answer. Now the second one, we want to find n is equal to 4. So we got P is equal to 100,000. Again, we're plugging into this formula down here, over 1 plus R, which is 0.09, divided by N, which is 4, raised to the NT power, which would be 4 times 20. Which gives us 100,000 over 1 plus 0.09 over 4, raised to the 4 times 20, which is 80th power. So we got 100,000 divided by, beginning parentheses, 1 plus 0.09 divided by 4, close parentheses, caret 80. Enter. And we get $16,862 and 99 cents. Okay. Now the next one is n is equal to 12. Same formula. So we're going to plug in everything we're given. A is 100,000 divided by 1 plus R, which is 0.09, divided by N, which is 12, raised to the NT power, which would be 12 times whatever T was, 20. So that gives us 100,000 over 1 plus 0.09 over 12, raised to the 12 times 20, which gives us 240 power. Okay, so we got 100,000 divided by beginning parentheses 1 plus 0.09 divided by 12, close parentheses, caret 240. Enter. We've got 16,641 and 28 cents. Well, now we got n is equal to 365. Same formula. Plug in 100,000 for A over 1 plus R, which is 0.09, divided by n, which is 365. Raise the nt power, which would be 365 times 20. Now this one, I'm going to put parentheses around the exponent and plug it in as you see it. Don't put any extra parentheses, just parentheses here, and then a times in between them. Okay, so we got 100,000 divided by beginning parentheses 1 plus 0.09 divided by 365, close parentheses, caret, beginning parentheses, 365 times 20. And I'll put a closing parentheses there, and then press enter. And we get $16,533.56. Okay. Last one. See, A is 100,000. R is 9%. 0.09, and T is 20. And it says continuous compounding. So that's our PERT formula. So we're going to be using A is equal to PE to the RT power. Now we're trying to get P by itself, so we're going to divide both sides by E to the RT. So I'll take A divided by E to the RT is equal to PE to the RT divided by E to the RT. Now E to the RT is going to cancel. And we got P is equal to A over E to the RT. So now we're going to plug in what we're given. P is equal to A, which is 100,000, divided by E to the R, which is 0.09, times T, which is 20. And we'll type that in without any extra parentheses. So we got 100,000 divided by E, which is second natural log, second ln, 0.09 times 20. Notice as I'm putting in the 0.09 times 20, I'm not putting any extra parentheses at all. And then press enter. And our answer is $16,529 and 89 cents.